Today we'll be looking at the 0-1 knapsack problem. It's called 0-1 because in the knapsack or the bag, the element can either be not present or be present. So hence 0 and 1. And we want to maximize the value of items in the bag such that the total weight in the bag is less than W, that is 1050 in this example. The values of the elements, that is their market value, we can say, are 450 rupees, 100 rupees and 500 rupees. And the weight are 100 kilogram, 500 kilogram and 1000 kilogram, let's say. The maximum capacity of the bag is 1050 kilogram, which is way too much, I guess. So we can have so much weight in the bag, but our main aim is to maximize the value such that the weight is less than or equal to this maximum possible. So the question is, what is the maximum value obtained? So intuitively, if we include 0 and first element in the bag, the value will be 450 plus 100, that is 550 rupees, and their weight will be 600 kilogram, which is less than 1050. So we are good. We have obtained 550 rupees elements. Other example is second alone. So we include this, just this. So 500 rupees, which is less than our first choice. The weight is 1000, which is still less than the maximum possible. But now we can't include the 0th element because otherwise the weight will be 1100 in that case. So the final answer will be 0th element, and the first element should be put into the bag so that their maximum value is reached, that is 550 rupees. So we are now talking about the algorithm to solve this problem. So if we consider the nth element, in the final solution, the nth element is either included or excluded. These are the two possible cases. There is no other possible case. Please convince yourself of this. Okay, so we will consider two cases one by one and hence exhaustively cover all the cases. So first is exclude. So we are excluding that element. So we still have W weight capacity and we recurse on the n-1 remaining elements. If we are including that element, we already have my val, that is the value of the nth element. We have achieved this, plus we recurse on the n-1 remaining with W minus Wn, that is my weight is now taken. I have got my value, but my weight is also taken. So let's say there is a recursive function which takes the elements and the remaining weight. So we can say that you take all the remaining n-1 elements. I have already added myself, so you can have W minus Wn weight at max, and your aim is the same as was previously, so we can recurse. So this is the algorithm. This is having overlapping sub problems. This 0-1 knapsack problem, so we can implement the dynamic programming approach for it. Let's consider a quick example where weights are 111, W is 2, maximum weight possible is 2, and values are these. In this case, the recursion tree will be this, and as we can see, K01 appears on the two of the leaves. Hence, we have overlapping subproblems. K01 we are computing twice if we are not using memoization or anything, or the bottom-up approach basically. So if we use memoization in this, we have to compute this only once. Similarly, K11 also is appearing twice, as you can see. So basically this shows this have overlapping subproblems, and hence dynamic programming is a suitable approach for solving this problem. And optimal substructure we have already shown for this, because this whole proves that this is having optimal substructure. So it is satisfying both the property of the dynamic programming problems which fall in the dynamic programming range. So we can solve it using dynamic programming. So I hope this thing was pretty clear with my explanation. I will just quickly reiterate on this. So if the nth element is included, I recurse on remaining n minus 1. Sorry, nth is excluded, I just recurse on the remaining n minus 1, and my weight is also, the remaining weight remaining with me is still w, capacity remaining is still w because I am not included. If I am the nth element, I am included, then I have added my well to the bag, and I can now recurse on n minus 1 remaining elements with w minus w and weight still remaining, weight capacity is still remaining in the bag because I am included in the bag, so this much capacity is still remaining. Hope this has made the things clear. Thank you friends, please like, share and subscribe.